Okay, good afternoon. So let us start this lesson. When I was watching the video, I realized that I messed up in one part and I deleted that from the previous video. Let me just describe it once more for you. So there was a function that I was talking about, f of x equals to the integral from 0 to 2x minus x squared cosine of 1 over 1 plus t squared dt. And we were supposed to calculate the so to see if this function has a maximum or a minimum, yes? Do you remember? So the first part, actually, we did it correct. So we calculate the derivative. So the derivative becomes, I have to replace t with this expression. So this becomes cosine of 1 over 1 plus 2x minus x squared, and then to power 2. And then I have to multiply by the derivative of that function. And then I told you that, okay, we put this equal to 0. And then we conclude that either this one is 0 or that one is 0. If that one is 0, immediately we get x equals to 1, which was correct. But the reason that I brought for you that this is actually not 0 was not right when I checked the video, okay? So probably I was distracted by this recording and things like that. So let me tell you why this cannot be equal to 0. So you see that this expression, 1 over 1 plus 2x minus x squared to power 2 is always positive. So you agree with that. Because 2x minus x squared, whatever it is, I raise it to power 2, it becomes positive or non-negative plus 1. So it is positive. But I hope that you agree with me that is also less than 1. Yes? Because this part is either 0 or larger than 0 because this is an even power. So this means that the denominator is definitely either 1 or bigger than 1. So it means that 1 divided by that 1 is also smaller than 1. Yes? And then 1 is also less than pi over 2. Yes? Because pi is 3.14 around that. And if you divide it by 2, definitely it is larger than 1. Yes? Pardon? Here? Yes, thank you very much. Yes, but anyway, this one is less than 1 pi over 2. So this means that this expression is in between 0 and pi over 2 strictly. Yes, so this means that this, what you see here, if I call it alpha, so cosine alpha, alpha is between 0 and pi over 2. Yes, this means that this cannot be equal to 0. Because alpha is a number between 0 and pi over 2, and I'm talking about cosine of alpha. So I totally messed up in the previous lecture, so hopefully I can fix it now. Okay, thank you. We go back now to the lesson. So let me start with, so do you remember we talked about the integration by parts, and I told you that integral of u dv is equal to uv minus integral of v du, yes? This is the indefinite version of the integration by parts. What happens if I want to calculate a definite integral, say from a to b? Yes. If I want to calculate this, I can calculate in two different ways. Either for the moment I can ignore that this is a definite integral. I just calculate the indefinite integral using the previous method that we learned. After we found actually the whole expression for the primitive function, then I replace b and a into the final answer and subtract them. Yes, that's one way. But another way is actually you actually do it case by case. So you can say that I can calculate this from a to b, and I also calculate this from a to b. So that's also good to know about it. Okay, so for example, if you see, let me solve one of these questions. Before doing this question number 6 in example 5.48, let me solve this exam question together, and then we can solve the problem. Then we can come back to number 6. So this is exam 2019. Yes, so let me have my notes with me. Exam 2019. October 22nd, question 1, part A. So you are supposed to calculate this integral. Integral from minus 1 to 1, x ln of 2 plus x cubed. Oh, that's x squared. And then dx. Okay, so when you see this integral, I hope that you remind yourself about that theorem that I mentioned, yes? If you have a symmetric interval, it's always good to check if the function is odd or even. Might be, if this is the case, this will actually simplify the problem a lot. But unfortunately, this is not the case. Do you agree? So if this is my integrand, if I change x to minus x, I will get minus x squared ln of 2 plus minus x cubed. Yes? But this one becomes positive x squared. This becomes 2 minus x cubed, which is not the same function, which is not negative of the same function. So it is neither odd nor even. So even though this is tempting to give this 0, but this is not correct. So we have to calculate this integral. So if I want to calculate this integral, I hope by the experience we got in the previous lesson, you might realize that this is somehow related to the integration by parts. So what we can do here, I will not actually start integration by parts immediately, because you see that I have a function in my integral so that its derivative up to a scaling factor is also appearing there, yes? So 2 plus x to the power of 3 is a function. When I differentiate it, it becomes 3x squared. X squared is here and 3 is just a scaling factor. So I will not immediately start integration by parts. I use the substitution method, okay? But because I am going to use u and v later, so let me just use t for the time being, okay? So I would say that let t be equal to 2 to the 2 plus x cubed. Okay, then what happens? Then I immediately take the derivative of this. The derivative of that becomes 3x squared dx. But you see that what I need is x squared multiplied by 2 dx. So this will motivate me to calculate this in terms of my new variable. So this becomes a third dt. And I told you that because this is a definite integral, I recommend you to change the limits accordingly. So what do I mean by that? I would say that x is given to go from minus 1 to 1, but I want to know where t is going from, to where t is starting to where, okay? So instead of minus 1, instead of x, I put minus 1, so it becomes 1. Instead of x, I put 1, it becomes 3, yes? Yes, so this means that if I call this integral I, this means that integral I can be written as integral from 1 to 3, and then I would write ln of t. Then instead of x squared dx, I write a third of dt, so I put 1 over 3 out, and then I have dt. Yes? Understandable? Yeah. Okay, and then this is a famous integral. Hopefully you remember from the previous session that you can use this using the integration by parts. So, and then hopefully you remember that we take this one to be u, and the leftover, we take it to be dv. So when say that u is ln of t, then this implies that du that I need is 1 over t dt. And when you say that dv is dt, dv is dt, so it implies that v is equal to t. Okay? So then it means that the integral I is 1/3. Okay? And then let us go here. I want to use this one. Of course, you can momentarily completely ignore about these limits, calculate the integral, and then put the limits in. But let us use this version, okay? So I have u times v. What is u? U is ln of t. What is v? Is this one. So I multiply them. It becomes t ln of t. But I say it goes from where to where? It goes from 1 to 3. And minus integral of v du, yes? So v is this one. Du is this one. If I multiply them, t and 1 over t cancel out, and I will get dt. It goes from 1 to 3. Yes? Okay, so now I calculate the limit. So this becomes a third, and then I put 3 in, so it becomes 3 ln of 3. But then when I put 1 here to subtract them, ln of 1 is 0, so I don't need to write anything. And the primitive function for dt is just t between 3 and 1. Yes, so it becomes 2. So it becomes minus 2. So if you want, you can multiply a third in. So this becomes ln of 3 minus 2/3. So that's the answer. Yes? Is that clear? Okay, so let us do one more practice and come back to example 548, part 6. Yes? So we are supposed to calculate this integral from 0 to 1 square root of x sine pi square root of x dx. So how should I calculate this? Calculate this. So I don't know, by experience, I also feel, let us change the variable a little bit. Okay, so here, let me say let t be equal to square root of x. Okay, and then what happens? I can take the derivative of both sides. So if I take this one to be square root of x, then I need dx. So this means that x is actually t squared. And then this means that dx is 2t dt. Yes? But of course, x goes from 0 to 1. This then implies that t goes from where to where. If I put 0, t becomes 0. If I put 1, t becomes 1. So it means that that's a coincidence, that the interval does not change. Okay? So if I call this integral I, so far what I have done, I have written that I is equal to integral from 0 to 1 again. But instead of square root of x, I can write t. And then instead of sine pi square root of x, I can write sine pi t. But instead of dx, I can write 2t dt. Yes? Yes?
May I come with a suggestion?
Yes, please.
I think we could use the UDV formula straight away, because when we
Differentiate.
the derivative of
Yeah.
sine,
Yes.
we get the derivative of sine times the linear derivative, and that will be 1.
No, that would be 1 over d square root of x. It becomes 1 over 2 square root of x.
Yes, and I think that will cancel out with the other square root of x.
No. No, but let me see, because if you take this, might be that's the case. I don't know. Your suggestion is to take this one u and this one dv, or the other way around.
I think it was the other way around.
So if you take this one to be d, if you want to take this one u, then your du becomes what? It becomes cosine pi square root of x multiplied by the derivative of that, which is 1 over 2 square root of x. And then I will have dx. And then it might be that's also working. Let us check. So if you take this one and this one to be dv, then what is your v then? V becomes integral of this, which is x to the power of 1/2, so it becomes 2/3 x to the power of 3 over 2. Yes? So then uv, I do not have any problems. I can write this with that, so that is uv part. But then v du, v multiplied by du, it becomes actually x. But that also works, but not as simple as you thought. So it becomes another integration by parts. Might be that's also better, I don't know. But if you want, we can go through this. I wanted to get rid of this integration. I wanted to get rid of a square root sign, yes? But I'm not against that. To be honest, if you multiply v by du, x to the power of 3/2, and one of these square root cancel, and I will left with 1x. So x cosine this one, you can also solve it, but the problem is that, again, somehow it becomes very similar to this. It doesn't become easier. You can test it yourself. Okay, but the point is that, unfortunately, these 2 and 3 will be multiplied, so I have 2 times integration by parts. So it becomes from 0 to 1, and then I have t squared sine pi t dt. So this is my integral now. Okay, so what I have to do, I hope that you have the experience now. Which one is better to take u? If you remember, we take this one to be u, and this one to be dv. So then I will write this, that u is equal to t squared. So this immediately implies that du is 2t dt. And then I say that, okay, sine pi t, I take dv to be sine pi t dt. So this becomes what? V becomes the integral of that one, which is minus 1 over pi cosine pi t. This is my v. Okay, so the integral that I am looking for, I, is 2 times integral, so 2 times uv, which is minus 1 over pi t squared cosine pi t. It goes from 0 to 1, yes, and then minus integral from 0 to 1 v times du. In du you have a 2, in v you have a minus pi, you bring them out, it becomes positive 2 over pi, yes, and then t cosine pi t dt. Okay, let me ask you, any questions? Understandable? Yes? So what I have done, I have just changed the variable from x to t. So I changed my integral to a new form. The good point is that I do not have any square roots involved. Probably it is easier for our brain to digest the problem. And then, based on the experience you had from the previous lesson, you realize that it is a good idea to take this one u and the rest dv. If you agree with me, then this is the only way we can do it. If I take u t squared, I take the derivative, I get this one, and dv is this expression, so I find v by integrating this again, but the integral of sine is minus cosine, but I also have a factor, so I wrote this. And then I wrote u times v, this is my u, this is my v, so I multiplied them between 0 and 1, and minus v du, but v has a minus 1 over pi, and then du has a 2, so I multiply them and pull them out. I made the negative sign positive because of this extra negative sign, and then there is a t left that I multiply this here. Yes? But then again, you see that this is another integration by parts. So let us just do them separately. First of all, let us calculate this part. So this becomes 2. If I put 1 here, this becomes cosine of pi, which is negative 1. This is 1, so it becomes 1 over pi. And then when I put 0, this becomes 0, so everything will be cancelled. And then I will have a 2 over pi here. But then again, I will do the same thing. I will take this one to be u, and I will take this one to be dv. Okay? So do you need me to write that? Okay, so if I take u to be t, then immediately it becomes clear that du is dt. And if I take dv to be cosine pi t dt, then what happens? V becomes integral of this, which is 1 over pi sine pi t. Yes? And now everything that I need is there. So I open another pair of brackets and I close that one. So inside that, I have to write uv again. But this is u, this is v. I multiply them. It becomes this. It's also supposed to go from 0 to 1. Minus integral from v minus integral v du. What is my v? My v is this one, du is this one, so I pull 1 over p out, and it goes from 0 to 1, and then I have sine pi t cosine, sine pi t dt. Yes? Okay, but what happens for this term? It vanishes completely, because if I put 1, sine pi t is 0. If I put 0, it is 0 because of this t. So this term completely vanishes, and this is what is left for me. The integral of sine is negative cosine. So if I want to simplify everything, so I have 2 here, 1 over pi here, and then plus 2 over pi here. This vanished, and then I will get times minus 1 over pi, another minus 1 over pi comes in, so it becomes positive pi squared, and then I have cosine pi t, and then this goes from 0 to 1 again. Yes? But if I put pi here, okay, we have to calculate this. So this becomes 2, 1 over pi plus 2 over pi. If I put 1 here, cosine pi is minus 1, so it becomes negative 1 over pi squared. And then if I put 0, it becomes 1. So it becomes negative 1 over pi squared again. And then you can simplify this a little bit, so that is your integral. Is that understandable? So if you want, we can simplify this a little bit. So this becomes 2, 1 over pi, and then this becomes minus 4 over pi cubed. And I multiply this, so the answer is just this number. Any questions? Okay. But now let us go to another exam problems, because there are no time, so I have to teach you a little bit when I am doing these integrals. So let me just do some of these integrals in which we have polynomials divided with each other. So we want to talk about how we can solve the integrals of polynomial px divided by another polynomial qx dx. Okay, so there are some cases we have to consider. So I will go only through these problems from the exam and try to teach you how to do this at this level, okay? So the important part is that we want to solve this when the degree of the polynomial of x in the numerator is less than the degree of the denominator. Yes? We want to do this because if the degree of the numerator is greater than the degree of the denominator, using the long division, you can change it into you can reduce that problem to a problem of this type. Okay, so the important thing is that if you have a polynomial divided by another polynomial and you want to integrate it, in principle, this case is important because other cases can be reduced to this case. Okay, so that's the idea. For example, let me solve this exam problem. And this is actually what I am talking about, is not integration by parts. It is the method of partial fractions. And I want to describe it only through examples because otherwise we will not be able to finalize. So this exam question, this is exam 2020 03011, question number 1. Okay, so you want to evaluate the following integrals. It integral dx divided by x squared minus 4. So why this is of that type? Because the denominator, of course, is a polynomial of degree 2. You can immediately see. But if I ask you what is the numerator is also a polynomial, but a constant polynomial, yes? So the degree of the polynomial in the numerator is 0. The degree of the polynomial in the denominator is 2. So the degree of the numerator is indeed less than that. So what we have to do, we can factorize. We want to use the method of partial fractions. What does it mean? I will take this one, this fraction, and I factorize the denominator. So this becomes x minus 2 and x plus 2. Okay, And then I want to write this as the sum of two partial fractions. How? I will take this, for example, I put it in the denominator, and then I put a number a, which is still undetermined. I want to determine that a, and then plus, I put this as the denominator of the second fraction, and I put a b in the numerator. So I want to fine-tune this a and b so that this fraction can be written as the sum of these two fractions. So these are called partial fractions, yes? Why this is useful? Because if I can manage to find an a and b in a proper way, then instead of integrating this function, I can integrate this function. But integrating of this function is easier than the original one because I can integrate the first one plus integrating the second one, and both of them are very actually famous ln functions, yes? We can come back to it later. But for the time being, let us try to fine-tune these a and b. Okay, so how should I do that? Just a very simple algebra. So what you do, you just copy and paste this part once more. Or I think it is easier, this is easier to do it. Multiply everything on the left and on the right so that you get rid of all fractions. Okay, so I multiply the left and right by this expression. If I multiply the left by this expression, this will be cancelled and 1 is left up there. Yes? But when I multiply this expression by the first fraction, x minus 2 part and x minus 2 are cancelled. X plus 2 is left, that I multiplied there. And then plus, I will do the same thing again. I take this denominator and multiply it here. X plus 2 part will be cancelled by x plus 2. X minus 2 is left, which will be multiplied there. Yes, is that understandable? Okay, and then you organize the right-hand side. What do I mean by organizing? I want you to write this, a polynomial, in a standard form. In a standard form means that if x appears, it should appear in one place. If x squared appears, it should appear in one place. Okay, so if you expand that, this becomes ax plus 2a. And if I expand that, it becomes bx minus 2b. Okay, and then x appears here and there, but I want to write it in a standard form, so I want x to be in one place. So this means that I factor x out, and then the coefficient becomes a plus b. And then I have 2a minus 2b, which is actually a constant number. But remember, my goal is to identify, I want to make this identical with 1. For every value of x, not just one single value. So this cannot happen unless the coefficients are exactly the same. So is there any x on the left? The answer is no. So this means that a plus b, which is the coefficient of factor x, should be 0. What is the constant number on the left is 1. What is the constant number on the right is 2a minus 2b. So this and that should match. Yes? So this will give you a system of two equations in two unknowns, and then you solve the system and you find this. For example, if I multiply this by 2 and add it here, so what happens? 2a plus 2a becomes 4a. This becomes cancelled, so a becomes 1 over 4. And then I put it here, b becomes negative 1 over. Yes? Okay, and then what happens is means that now I know what are A's and B's. Okay, even I think for this very simple problem, if you guess, that's no matter. But if the problem becomes a little bit complicated, guessing becomes harder. So you have to know a systematic way to calculate. Okay, but then what happens? Let me call this integral I. So my I becomes integral of this expression, which is equal to that. So I take the integral of this and that separately because I have addition between them. But now I know a is 1 over 4, b is minus 1 over 4. So if I integrate this where a is 1 over 4, 1 over 4 goes out, and then I will have integral of 1 over x minus 2 dx. And for the next one, b is negative 1 over 4. So it becomes negative 1 over 4 integral of 1 over x plus 2 dx. Yes? Understandable? Okay, now my question is that Of course, in principle, you need to use the substitution method, but I don't think if you write the answer, they will actually deduce any points from you, because this is very, very trivial. Can you tell me a function whose derivative is 1 over x minus 2? Clearly, it's ln, yes? So what you write 1 over 4, but don't forget to write ln of absolute value of x minus 2, then minus 1 over 4 ln of absolute value of x plus 2, and then you write a constant c at the end. Yes? But sometimes in books they simplify this a little bit. For example, they factor a 1 over 4 out, and this becomes ln of this minus ln of that, but that's also another formula, so you can write ln of the division of these two expressions. So I can write it as x minus 2 over x plus 2, and then plus c. So it might be in books you get this answer, but both of them are equivalent. Is that understandable? So this is one method. For example, let me solve the next one as well. So this is exam problem 2020 10-15, question number 2. So you are supposed to evaluate this integral. So integral x plus 4 divided by x squared plus 2x dx. So first of all, I want you to understand this is the new lesson. Why? Because you have an integral, you have a fraction, the numerator is a polynomial, the denominator is also a polynomial, but then you realize the degree of the numerator is 1, the degree of the denominator is 2, so indeed the degree of the numerator is smaller than the degree of the denominator. So what we should do, first of all, you try to use the partial fraction method of partial fractions to do something like this. So what you do, you write x plus 4 divided by x squared plus 2x. You first of all factorize this. So you write x plus 4, factorize the denominator, x times x plus 2, okay? And then you want to write this as the sum of two functions. Of course, the number of, two fractions. The number of fractions depends to the number of factors. If you have 2, there'll be 2. If you have 3, there will be 3, okay? So what you can do, of course, what I am talking about is not completely precise, because it might happen that you face a second degree polynomial after factorization. Okay, but then of course you have to change it. But because there are no time, if you want, you can study the rest in the book. But I haven't seen questions of those type in the exam. We will see also the other one to see how it goes. But anyway, so I mean that if it happens that one of them is a second degree then this is not exactly that what you have to do. So I will tell you what to do then. So this becomes x. Sorry, you write x in the denominator here. You write x plus 2 in the denominator here as well. But in the numerator, you put a number a, which is not known yet, and you put a number b, which is not known yet. And you try to find these a and b so that this fraction can be written as the sum of two partial fractions. If we succeed to find a and b, the problem again becomes extremely simple, yes? Because instead of integrating this, I can integrate this, which is an ln function, integrate this, which is also an ln function. Is that clear? Okay, so what I'm supposed to do, as I told you, it is better to get rid of all fractions. So if I want to get rid of all fractions here, I multiply everything by x and x plus 2. When I multiply the left-hand side by x and x plus 2, this is totally gone, and what is left for me is x plus 4. Okay? Now, you take this one in your head and multiply it here. This x in the denominator will vanish this x that I am multiplying. X plus 2 is left that I multiplied in the numerator. Yes? And then plus, I multiply this here. This x plus 2 will cancel this x plus 2. X is left. I multiply that x up there. As I told you that you need to organize the right-hand side in a standard form. So in the standard form, it means that you expand this. It becomes ax plus 2a, and then plus bx. So, and then you write x plus 4 is equal to, you see that x appears here and there. You want to have it in one place. So you factor x out, it becomes a plus b, and then I have a 2a there. But you want to make, by fine-tuning a and b, you want to make this polynomial identical with this polynomial. This happens if and only if the coefficients are correspondingly equal. So this means that I can conclude a system of equations. A plus b is the coefficient of x. The coefficient of x here is 1, so it means that a plus b should be 1. And the constant term is 2a, the constant term is 4, so this means that 2a should be 4. But this is a very simple system to solve, because from here you get a equals to 2, and you put it back here, you get b is equal to minus 1. So now you know that a is 2, b is minus 1. Okay? And this is easy to check. So if you see, for example, if instead of a I put 2, instead of b I put minus 1, and if I take the common denominator, then you see that this will go there, so it becomes 2x plus 4. And then this becomes minus x. So you see, this becomes exactly this. Okay, so what we can do now, we can write this integral I. So I becomes equal to the integral of this one plus integral of this one. But now I know a is 2, so I put 2 outside. It becomes integral of 1 over x dx. And I know b is minus 1, so it becomes minus integral of 1 over x plus 2 dx. Yes? And then, of course, you know what to do with these two integrals. So this becomes 2 ln of absolute value of x. This becomes minus ln of absolute value of x plus 2. And then you have a constant c at the end. If you want, you can simplify this. It doesn't matter, of course. You can write it as ln. You put these 2 up there, and then you have 2 ln subtracted. So you can write ln of absolute value of x squared divided by x plus 2 if you want to. So you can just write it in this form. Yes? Is that clear? Okay. I think for the next one, you don't have any problems. What happens if I have, for example, this scenario? Let me also tell you this. It becomes a little bit harder, but hopefully you can go and read in the book. If you have questions, you can come back and ask. For example, what happens if I have this scenario, x plus 4, and then I have x to the power of 2, but then I will have times x to the power of 2 plus 2. So you see that I cannot factorize it anymore. This x to the power of 2 plus 2 in the realm of the real numbers remain the same. In this case, the partial fractions are a little bit tricky. Okay, so this is a first order. So this can be factorized, of course. You can write it as x times x, but the factors are the same. If this happens, you write a with one factor, x, but remember, you put another b with x squared again. So, okay, so be careful. This is x, but this is x squared, but this x squared is actually a product of x and x. This you need to remember. If something like this happens, then you don't just write a over x. You have to write a over x, and then you write b over x squared. Okay, but then when I reach to this one, which is a second degree polynomial and cannot be factorized to smaller polynomials, then I write this x squared plus 1 plus 2, but what I have to do, I have to write a first degree polynomial in the numerator. So I have used already a and b, so I write cx plus d. Okay, so that would be actually time consuming. Sometimes it is really tedious to calculate a, b, c, and d, but the method is the same. Okay, so I really recommend you to try to find a, b, c, and d in a way that this is identical to this expression. Okay, so I don't know exactly are these included in your course or not, but I think, I don't know, have you studied them systematically? But you have studied them, yes, because they are in the exam. Okay, so might be you don't need to understand that. Like, good. But let me also go to the next one. If you see on this here, this is not very hard. This is exactly of this type. Can you tell me what to do with this one? What to do with this one? Yeah, we can factorize it easily as x minus 2 times x minus 3, and then I can use exactly the same method that I used here. So if you don't mind, let me just skip this one. But let me just do the next one. Yes, because the next one is the first type of examples that you see the degree of the numerator is larger than the degree of the denominator. And then you have to use the long division method or any other method that you can reduce that problem to a problem of this type. But the long division method is the best way to do that. Okay, so this is exam question 2019 0308 and question number 2. So we want to integrate all primitive functions of this function. So if you don't mind, let me just immediately start by writing it in the form of an integral. So x to the power of 3, 2x squared minus 4x, and then I have minus 1 divided by x squared minus 1 dx. So be careful. The method of partial fraction, you shouldn't apply it directly, because still the degree of the numerator is larger than the degree of the denominator. So when this happens, you go and do the long division. So you divide the numerator by the denominator. Yes? And then what happens? You take the first term and then divide it by the first term, it becomes x. You multiply x in the whole expression and write them with the opposite signs here. So x times x squared becomes negative x squared, x cubed. It becomes positive, but I change the sign myself. I multiply x by minus 1, it becomes negative x, but I change the sign, yes? And then I will add this polynomial to that polynomial. If you don't change the signs, you have to subtract them. That's up to you what to do. For me, it is easier to change the sign, not to get confused because of minus signs. Okay, so when I add them, this one and that one are cancelled, but it is not, you cannot add this one to this one. So you bring 2x squared down. It's important. The order of the powers should be in the descending order, yes? And this x will be added to this minus 4x, gives me minus 3x, and then minus 1, I bring it down, yes? I do this one once more, until the degree of what is left here, which is called the remainder, becomes either the remainder becomes 0, or the degree of what I call remainder becomes smaller than the degree of this expression, which we call divisor. So I do this once more. 2x squared divided by x squared is positive 2. I multiply 2 here and there and change the signs here. So this becomes negative 2x squared minus 2, it becomes plus 2. And then when I add them, these two are cancelled. Minus 3x is just minus 3x. I bring it down, but 2 and that one becomes 1. Can I continue the process? The answer is no, because the degree of the degree of what is left, which I call the remainder, is 1. The degree of the divisor is 2, and it is smaller. So the process stops here. And the process, when the process stops here, what does it mean? It means that the numerator is equal to this expression, which is the divisor, multiplied by that expression, which is called the quotient, yes, plus the remainder, okay? It's exactly like this. If I ask you divide 21 by 5, what will be the quotient? The quotient will be 4. What will be the remainder? The remainder will be 1. And then if you multiply 5 by 4 and add the remainder to it, you will get this number back. You can immediately, if you forget, you can just remind this yourself. Okay, so now what does it mean? It means that if you want to test it, how do you test it? You multiply these two and add them here. So definitely you will get that expression if I haven't done something wrong. But what is the benefit of doing this when it comes to this integral? Because now this fraction, x to the power of 3 plus 2x squared minus 4x minus 1 divided by x squared minus 1 can be written as, instead of the numerator, I write that expression and then divide it by this. But because that's the sum, I can separately divide. So I can divide this expression by that, and this expression by that. Yes? And now what happens, this one and that one are cancelled, so this expression becomes x plus 2, and then I have plus, if you don't mind, in the numerator I write 1 minus 3x, and then I have x squared minus 1. So we realize that this fraction can be written in this form, and I want to integrate. When I want to integrate, I should integrate this one, which is very simple. I should integrate this one, which is very simple. And at the end, I should integrate this one. But we learn how to do this, because now this is a fraction of polynomials, but now the degree of the numerator is less than the degree of the denominator. So you see that you reduce this harder problem to a problem that you already know how to solve. Yeah, is that clear? Okay, so I don't think we need to continue here. So if you want to integrate, the integral of this one is x squared divided by 2. This is 2x. The only problem is here, but you know that you write 1 minus 3x. You factorize this. It becomes x minus 1, x plus 1. And then what you write a over x minus 1 plus b over x plus 1. Yes? And then as we did before, you find a and b, and then you are done. Yes, is that clear? Okay, so I think now we can have a break so that I can have time to clean the board.